There we go. So our meeting's going to now be recorded as I've talked about. So first off, welcome to our first lecture. I am super excited to be here. Um, it's been a Monday, and that's how these always are. This class has always been done on a Monday, hence the reason we're still doing it this way, even though we're virtual here. If anybody has problems hearing me or anything like that, please let me know so I'm just not talking into a blank screen. So please let me know. Jennifer had a question before this began when we talked about academic integrity. I'll be honest, I did not update that part of what my expectations are you during quizzes, tests, and everything like that. During a quiz, honestly, you are your own boss. The quizzes are there for, kind of bonus points and everything like that. And I don't think I discussed something, so I'll go back to that to make sure you guys understand how quizzes work. When it comes to exams and the midterm and the final, those are all timed. So it is in your best interest to obviously be prudent to know your information while you're taking it, because if you are looking things up, again, I can't monitor you. I want you to get everything out of this class that you would like to get out of this class. So therefore, if you want to use some notes or something like that, I can't stop you. This class is not proctored. So the bottom line, if you want to, great, just be very mindful that anything that is not submitted when the time is up, the rest go unanswered. So I guess, Jennifer, does that explain? Hopefully it does. Hopefully it does. Perfect. Thank you. There we go. Okay. Also, just to let you know about the quizzes and, participation, those I call buffer points for this class. And again, if I did talk about this in the syllabus slide lecture that I did last week, just bear with me. But the nice thing about the quizzes is I do, go through, try to do as many, or, you want to try to get as many points as possible with those. Basically, what the nice part is, I drop the final or the worst two, and then those two become extra credit points. So for example, let's say your lowest quiz score was an 8 out of 10 and maybe a 5 out of 10. Well, I would drop that 8 and 5, and then all of a sudden becomes 13 points of extra credit to be used at the end of the class. So hopefully that makes sense, but it really does kind of work out nice. It's a little extra buffer and everything like that. So hopefully that helps a little bit here. So are there any questions before we dive into lecture material?
I had a question about the textbooks. Is it okay to ask that now?
Yes, yep, absolutely. If there's a textbook question, for sure.
So I was just wondering if have you had people use Bookshare in this class, or I did notice that they don't have the editions that you're asking for. They were a little bit behind. So and yeah, anyway, I'm trying to think what my next best plan is to get those.
I do know that there have been folks that have used Bookshare. I'll be honest with the material. Please know if you use an older edition, that is not going to impede you. The books are there to be a resource just for, some extra material. So please know that if you want to use an older material, basically the biggest thing with the newest edition, the stuff that's been updated is more pharmacology stuff, the stuff that's I'm not going to talk about really in this course. There might be some new technology stuff. Again, I'm not going to hold you to that. I only quiz and go over stuff from the actual lecture itself. So, the questions and everything that you'll see on any type of examination will come from the lecture. It will not come from the book. So if you use an older version of the book, please rest assured that you will be okay.
Okay, awesome. Thank you.
You are welcome. Again, I tend to give long answers, so hopefully that's okay here. And then also, please know that there are a lot of texts being going on in the class and everything. So please read the chats because there's some your fellow colleagues have some great information here. Okay, about that.
Dr. J,
Yes.
can I say something about the book?
Yeah.
If you go to the library, the WMU library, where we do research, books and media, if you click on books and media and you put the ophthalmology assistant in there, the current text comes up there and you can view it online.
Oh, that's great news. Perfect.
And then also, somebody is not muted, and it's given a lot of feedback, and a lot of students are commenting on that in the chat. I think it's the one that has a number 4797.81. If you can mute yourself, please.
I'm not sure how to mute being on audio,
Okay.
but if somebody can tell me, I'd be happy to mute.
I think I can mute everybody, and then if you go through and mute, let me see. Hopefully, it doesn't mute myself. There we go. There we go. Okay. So I went through and muted everybody. And just please unmute yourself if you have any questions or anything like that. Sometimes I don't catch, as I'm lecturing, I may not catch a hand raised or anything. But please feel free, pop it in the chat and we'll go from there. So perfect. So I think we're doing good. Okay. I am going to go ahead and start lecturing. So I feel that if there is one lecture you want to pay attention to, it is literally this lecture. There is going to be so much information, lots of new terminology. We'll go through, we're going to learn this here together. I'm hopeful that I'm just a guide, a resource that really helps you. But this stuff is the bread and butter of the entire course. The rest of the course kind of builds off of tonight. So no pressure, but basically it is literally just so much vocabulary. And again, you may not have had a lot of this type of class where you have all this medical terminology, and that's okay. But that's why I do record these and let you know. There is another recommended book that is the Dictionary of Eye Terminology. That's actually a really good resource as well if you do want to take a look at that here. So, but as we go through, I'm going to try to be as explanatory as possible, if that's a word. I might make up my own words throughout this. You know, we're going to have fun. It's been a long Monday. So here we go. So we're going to start basically the outer eye inward and kind of go from there. So we're going to start with the outer of the eye. So first off, we have the eyelids. These are literally movable folds of skin that go over top of the eyeball itself. It protects the eye from injury and excessive light. Basically, if something comes close to the eye, those eyelids close, and that is a great form of protection. One of the other important things is it also spreads tears over the eyes. The eyes need to maintain a moist environment, and so therefore the eyelids themselves actually spread over the tears, or spread the tears over the eyes in order to help them out. Now, the opening between the upper lid and the lower lid is called the palpebral fissure. You'll see that word palpebral in a few other instances as we talk tonight, but palpebral itself basically is the medical term for lid. So when you say a palpebral fissure, fissure meaning opening, a palpebral fissure is the opening between the upper and lower lid. So that's how we see when the eyelids are open, that palpebral fissure is open. We can see when the palpebral fissure is closed, the eyelids are closed. So hopefully that makes sense. The upper lid is more mobile than the bottom lid. That is where we get most of our movement from. The levator palpebrae superioris is the actual eye muscle that does the work. It lifts open the eye. If you think of elevator, therefore you have levator. So hopefully that helps out a little bit. But again, that opens the upper lid, so therefore we can see. Within that upper lid, we also have what's called the tarsus. This is an area of protection. And so therefore, it's a very thick layer of connective tissue. So heaven forbid something happens where it pokes your eye. It's not just skin, which is very movable. You know, it's an actual layer of substance that blocks you from just penetrating the eyelid. So it ultimately protects the eyeball. Because, you know, last time I checked, the eyeballs are pretty important. So in the area nasally of the eyeball itself, or the eyelid, we have the canthus, and this is basically towards the nose when I say nasal. And then we have the caruncle. This is the area of fleshy material when you wake up in the morning and, you know, there's that mucus and just the eye crud, and the really technical name that my 4.5-year-old would love is boogers. That's where the eye boogers are kept, is the canthi. So if that gives you a good area. So right in the caruncle, it's an area with so many sweat and oil glands with fine little cilia. Cilia are basically just fine little hairs. And basically it's all about microbes, or catching microbes to help protect the eye from getting sick. So that's all we're going to say about that. But when we go back to the eye muscles, we also have the orbicularis oculi. This is a round muscle that goes around the entire eye that helps you close the eye. So we have the levator that opens that upper lid. Now we have the orbicularis oculi that does the opposite. It closes the eye. Then we also have these things called eyelashes. No, whatever the beauty industry thinks, they're not for beauty. They're actually for protection. Because what happens when you feel something touch your eyelash? You blink. That helps you protect your eyes. So again, the eyelashes really are one of those natural things that really help with protecting our eyes. And so therefore, if it feels something, they instantly close. So therefore, it again gives a layer of protection. Next up, we have the tears and drainage. So this would be just underneath those lids. And the tears are formed from the lacrimal gland, the meibomian glands, and the goblet cells. We'll talk a little bit more about those specific glands, but basically what I want you to know is, yeah, there's 3 different glands that make up everything that happens to be inside the tears. And basically the tears are swept from the ears towards the nose, because again, that's where the tears drain. So they want to start out, you know, the big lacrimal gland is actually on the outer side of our upper lid. And that's what really supports the thick, or the heavy water area of the tears themselves. And so again, they're swept from the ear towards the nose, to give you an idea. And they land basically in the punctum. Now, the punctum is a very small hole near the caruncle. And basically, again, it's on the upper lid and lower lid. These are small little tubes that help remove the excess tears from the eyes. Again, there's the canaliculus, which is a smaller tube, and then it all runs into the lacrimal sac, which is inside our nose. So therefore, when your eyes run, you know, you've got excess tears, they're going to go into the puncta, through the canaliculus, and ultimately in the lacrimal sac that lands in our nose. So therefore, if you feel yourself get more snot, so to speak, I'm being very technical now. When you get more snot, when your eyes are watering up or whatever, that is why, because those tears, those excess tears, are landing in your nose, not just going down your face. So hopefully that helps a little bit. So the function of the tears, why do we even have them? And yes, like when you're crying, this is exactly why your nose runs more when you're crying, because again, those excess tears are going through the tear exit system, is what we're going to call it here, and ultimately land in your nose and then down your face if you don't have a Kleenex available. Oh, just wait, Alex, get more snot. Just letting you know, there'll be many, we'll call them madisms here. It only gets worse from here. We're all adults, so let's just put it that way. So I'm being asked by Eric, can you elaborate on the difference between the canthi and the punctum? So the punctum itself is the actual hole where the the tears actually drain out. So that's in the upper and lower lid. And then the canthi itself is the fleshy area. The canthi is the opening. Right near the actual tears. Again, I'm not going to be that specific. Please let you know. about which is the canthi and which one's the punctum. So please know that I'm not going to ask. What I really do want you to know is the tears initially go through the punctum, through the canaliculus to the lacrimal sac. So that's as far as I would ever go. So yeah, no problem. Thanks for the questions. So what do the tears do? They basically form a smooth refractive surface on the corneal epithelium. The cornea, which is the very top layer that starts the actual eyeball itself, doesn't really, it likes moisture, but it doesn't want to attract moisture. So the tears are a very pH balanced substance that literally helps us keep moisture on the eyes. It maintains that moisturized environment for the corneal epithelium, the very top layer of the cornea, and it also carries oxygen to the cornea. So again, it creates a smooth surface to get any irregularity out of the front surface of the eye. It maintains that moisturized environment, which the corneal epithelium needs in order for us to see. And then it also carries oxygen to the cornea. So there's 3 different things that the tears actually do. So that's how I've kind of broken this down from the front portion of the eyes. Now we're going to get into the globe or the eyeball itself, and we call that the anterior segment. This is the very front structures and whatnot here. So hopefully this helps out a little bit as we continue to go through. So the first thing that we're going to talk about is the actual sclera. The sclera itself is opaque. It is the white part of the eye. It actually forms 5/6 of the back of the eye. The other 1/6 is the cornea. So you can see how much the sclera goes all the way around. This is how the eye is made of its sphere. And so this part is extremely important. It is connective tissue. Just like we talked about connective tissue in the lid, we also have this connective tissue part, and that makes up the sclera because it makes the eye strong. It tries to make it so it cannot be penetrated by anything. So therefore, it allows the passage of nerves and blood vessels. That's pretty important because obviously the eye is an extension of the brain, so it needs a lot of blood and nerves and everything like that in order to actually function. The biggest nerve that actually goes through the sclera is the optic nerve, and it goes through that at the lamina cribrosa. The sclera basically is just all one structure until it hits where the optic nerve goes through, and then it becomes kind of a spongy material. Well, let's call it Swiss cheese material because it's got lots of holes, and so that's where the optic nerve actually goes through. So again, the sclera does have a hole-like structure called the lamina cribrosa, and that's where the optic nerve itself goes through. It also has the episclera, which is a more vascularized section that has both elastic tissue and connective tissue to give the eye just a little bit of bend, if you're, out on a Friday night having a good time and, you get in a bar fight or something. I'm just kidding. That's not recommended. Don't do that. But again, the eye has to have some give. And again, please forgive my sense of humor. Next up, we have the conjunctiva. This is a mucous membrane that actually covers the sclera. So we have the sclera, that white part that you're able to actually see if you're looking at somebody's face. And then we have this conjunctiva. The conjunctiva, again, it's a mucous membrane covering it. So it's a very thin layer. If you're familiar with saran wrap or, some type of that plastic material that covers food or something like that, it's literally like that. It's so thin and it's transparent. You can actually see this. And yes, this is the part when conjunctivitis, you get a conjunctivitis. Such a good question. This is the part that gets inflamed because it's a mucous membrane and that can get inflamed. So we have 2 parts. We have that palpebral, which again, we talked about that before with the palpebral fissure. So the palpebral conjunctiva is actually on the lids itself. And then we have the bulbar, which is on the eyeball. So the conjunctiva is continuous from the eyeball to the lid. And the most important part of this is we call it, this continuous structure because, for example, if you've ever heard of somebody saying, oh my gosh, I'm going to lose a contact lens behind my eye, that's actually not possible because it is a full-on connection from the lid all the way onto the eyeball itself. So there's no way anything can get to the back of the eye. I mean, you probably have never wanted to think about this, but can you imagine the things that could get inside our eyes and go behind and then has access to our brain if we did not have the smooth connection between our lids and our eyeballs? I mean, it's ingenious. The human body is freaking amazing. And this is just one of those different ways. So no, you are right, Lisa. You actually cannot lose a contact behind your eye. Now it can get folded and hide up underneath your upper lid or something like that, but it will never go behind the eyeball itself. So you can rest assured. I mean, you've got to have something sharp and penetrate to get back there. And oh my gosh, we're going to have so many other issues if that is indeed the case. So we also, we have the fornix. This is the part that surrounds the cornea area, because again, the conjunctiva goes right up to the cornea, which is the clear area. That's where all our vision comes in. So that fornix defends and repairs the cornea. Very, very important. It also catches microorganisms. So that's part of the reason why when we have mucous membrane, it's sticky and then it releases its stuff into the tears. And that's why when you're outside and if you've ever had the area where you're like, oh my gosh, my eyes are so irritated and stuff like that because of all the dust and whatnot, and then you wipe your eyes and you're like, ew, that's gross. Well, it's your conjunctiva saving and getting all that crap out of your eyes. So hopefully that helps. So again, the reason why it's that mucous membrane, what makes up the mucus, it is made up of secretory elements. So we have nutrients, we have antibodies, and we have leukocytes. The blood vessels themselves are doing the secreting of this stuff. Antibodies and leukocytes are both part of the immune system to help keep our eyes healthy. So they're going to fight whatever crap that we get into that goes to our eyes here. So from the cellular components, it does secrete mucus and oil that both become part of the tear film. So we do get some of our tears from the conjunctiva, not just the other part here. Again, like I say, next week we'll go into that a little bit more here. Next up, we have the cornea. This is a transparent, clear, and shiny area. I can't help but think of shiny from Moana whenever I hear that word, so I apologize again, toddler dad here. But the cornea itself is convex, and it is fully developed by the age of 2. The rest of the body might be developing, but that cornea is its full size by the age of 2. It has a certain thickness. The thickness is maintained, so therefore the eyeball doesn't pop like a balloon, because again, it is a globe structure with stuff in the middle. We'll talk about that stuff here in a minute. But basically at the limbus, which is right where the fornix is, that area where the conjunction zone is between the cornea and the conjunctiva, we have the fornix and the limbus itself. The limbus is the actual transition zone. That's where the conjunctiva gets inserted, because again, at the cornea, there are no blood vessels, and we'll talk about that. So let's see, we mentioned nerves, and I have told that we cannot feel pain in our eyes, but I beg to differ when you put eye drops in and when we accidentally touch our eyes. So when you're told that you cannot feel pain in your eyes, there's a big difference, because the outer structures, absolutely, you feel pain. If I get something under my contacts, good Lord, and anybody that wears contacts are going to say, yeah, I know I've got nerves. Now there's 2 different nerves. We have sensory nerves, which feel, or, how do I want to word this? There's 2 different kinds of nerves. There's the nerves that kind of transmit information, and then there's sensory nerves that actually touch and feel and things like that. The whole front of the eye itself, on the cornea, on the conjunctiva, has all these sensory nerves. So when you feel something, they're all exposed. So therefore you close the eye. You feel pain, you close the eye, you protect your eye. In the back of the eye, on the retina, those are like visual nerves. So again, there's not the feeling that you get if there is something penetrating the back of the eye. For example, if you're getting laser or something like that, there's so much protection and there's so much to get through that you're going to already know that something bad is going on with your eyes. So therefore, hopefully that helps that question. But yes, there are those, we'll just call them ouchy nerves that are all over the surface of the external part of the eyeball that really helps us know, okay, we got something going on here. We need to protect ourselves. So hopefully that helps that question, but that was a good one. I like it. You guys are involved. This is making my life fun. Okay. So we do have 5 layers of the cornea. So this is where it's, the anatomy part. So it's a lot, I know I'm giving you a lot of terminology here, but I'm trying to have fun doing it. So the epithelium, the very outer part, this touches the actual tears. It's about 50 microns or just 5 decels thick. It's very, very thin. It is the barrier and refractive surface that you can see glistening off the eyes. It is very rapid regeneration. So if it gets scratched, it hurts like the dickens, or you put an eye drop in and you feel it. That's where it's coming from, because those nerve endings are all exposed for that reason, but there's no scarring because it regenerates so incredibly fast. Just below that, we have Bowman's layer. This is an acellular 10 micron thick layer. Whether or not there's an actual cell there, it's just a different section of the cornea, but they call it Bowman's layer as it goes into the stroma. The stroma is the thickest layer of the cornea, and it's about 78% water. The rest are just kind of collagen fibers that kind of make it up and make sure it stays transparent. Just below that, as we go towards the eye, we have Descemet's membrane, which is 3 to 12 microns thick. It is called the basement membrane. Whenever you see the term basement membrane in anatomy, it means it's holding on to something so something can attach to it. And then basically, we have the endothelium, which is 4 to 6 microns thick, but there are only 500,000 cells, and that's what you're born with. By 2 years old, they will never create another endothelial cell. And the biggest important part of the endothelium is, we talked about the stroma having the water. The endothelium is like a dam that keeps that regulated, so it's the perfect amount of water in order to have the appropriate part of water, because if there's too much water or not enough water, the visual quality is going to dramatically decrease. So the endothelium is so incredibly important, and you don't want to lose it. So Alex put, I find it so strange that some of these layers are, hold on, I just lost it. There we go, found my mouse here. I found it so strange that some of these layers have sciencey names and others have dead white guy names. I don't know why anybody would want their body named after something like this. I don't get it. I don't get it. But guys' egos are fragile. Oh my gosh, I'm gonna shut up now. Anyway, so there's that. And then this one, are you talking about all these layers? I can't but toss the fact that many eye drops contains BAK, a neurotoxin used for deep cleaning industrial labs. I know it's a rabbit hole we can't go down, but oh my gosh, Lisa, I gotta get on my soapbox. So this BAK, this neurotoxin used for deep cleaning industrial labs, that is a preservative that is in Visine. Go figure. This is what keeps all the bugs out of Visine. Don't you just want to put that in your eyes? Oh my God, don't ever use Visine. I might say that a time or two in this class. So the endothelium does not regenerate at all. It is what it is. There's nothing else that you can do with it. So when you have a thicker or thinner cornea, as long as it stays its proper homeostasis, so the best visual quality can go through, it's totally fine. So there's some people that have thicker corneas, there's other people that have thinner corneas. Where it matters, if you go through and get LASIK surgery and all of a sudden you're going to use a laser to adjust the refractive power of the eye, we'll get into all this slightly in this class, but that's when the thickness of the cornea really matters, because then it's like, okay, how much can I safely take away to not let all the fluid that's within the eye just come out? So therefore, hopefully that helps a little bit here. So it's definitely, it matters. There's different aspects that it matters and things to that nature here. So gosh, you guys are asking all the good questions. I love it. So how does the cornea get nourishment? Again, it is avascular. There is not one, or there's not supposed to be any blood vessels in the cornea. So again, there's a very plexus of these fine capillaries or these fine little blood vessels that are going to secrete the nutrients the cornea needs to keep everything happy, keep the cells fed. You know, you don't want to get the cornea hangry because, oh, good God, you're not going to be able to see through it. And then we also, the cornea gets nutrients through the tear film. There's nutrients in the tears and oxygen to give the cornea what it needs to keep, again, that absolute homeostasis to let vision penetrate it and come to our retina so we can see. So, and then there we have the aqueous humor, which is just behind the cornea. And that is a clear fluid that is between the cornea and the iris. So that also has special nutrients that do provide the cornea with everything that it happens to need. So next up, we're going to back up into the eye just a little bit more, and we're going to talk about the intermediate section of the eyes here. And I got a question. Can the cornea's thickness or thinness be contribute to conditions like Sjogren's? Generally, no. So I don't want to go down this rabbit hole quite much, but no. Generally, the corneal thickness is what you're born with. It's really genetically motivated. Having certain body diseases does not, or body pathologies do not actually cause the cornea to have a certain thickness or anything like that. Good question. So next up, intermediate segment. These are the middle structures of the eye. We have the iris, the ciliary body and muscle, and the choroid. So it's going to get a little bit more fun. We have the uvea. Again, that is the intermediate section. Again, if we have something in medicine, why not have 5 million names for it? Sure, let's have fun. Let's do this. So again, it consists of 3 different parts. We have the iris, we have the ciliary body, and the choroid. All of these make up the uvea. The reason they call it the uvea is because these are high blood vessel volumes. There are so much blood. There is so much need for energy to be extracted through this area. So a lot of blood flow in this area. So let's talk about it. So first up, we're going to talk about the iris. The iris is the most anterior part of the uveal tract. That's a fancy term for meaning this is the very first structure, the very outermost structure of the uvea. It is a central circular aperture. So it is it's a circle, and then it's got a hole in the middle. That hole, my friends, is the pupil. The pupil is nothing. There is literally just aqueous humor that flows within the pupil. It is anatomically dead space. There's nothing there. It's the iris that creates the pupil, and there are many different ridges and furrows. We all have our own individual look for what our iris can look like. So it's very, very specific. I would say much more specific than a fingerprint. And then it's got 2 muscles in it, the sphincter and a dilator. So the dilator, again, if it dilates, if you've been to the eye doctor, had an eye exam, I hope you have at this point. Kimmy, I'll get to that question about the dead space and how and why it can dilate. Is literally the muscles create that opening. So the opening itself is the pupil. And so we have the sphincter and the dilator muscles that control the size of the pupil itself. So again, when we talk about the pupil, it's literally just the hole that these create. So the dilator opens things up, just like if you're pregnant and you're dilated. Hate to use it, but again, most people know that, okay, I'm dilated, now I can have this baby. There's an opening for a baby to pop out. So there's opening for light to come in. And then we have a sphincter. Well, a sphincter is pretty important so I don't crap my pants at work. So that's another way to kind of work it. Oh my gosh, it's been a long day. I'm sorry. I hope you're just laughing at me right now. But a sphincter, again, tight hole, that creates, the pupil to get smaller. So light is not coming into the eye. So it's kind of controlling it. So we got the sphincter, small, dilator, big. Okay. Next up, we have the ciliary body. The ciliary body is a direct continuity of the iris. It is literally just behind it. So we've got the eye, we got the cornea, we got the aqueous humor, and then we have the iris. And next up, right around the iris, connected to the sclera, so it's right along the side, it's all around that circle there, it is the ciliary body. It is directly behind the iris. I like to call it, it is plump with many folds. I think of Mrs. Potts, just plump with many folds. I don't know, maybe she really doesn't have many folds, but that's what I just determined. The 90s movie, not the remake. Okay. So anyway, it's very small. It's about 2.5 millimeters. And this is the reason I bring this up in this class is the production of aqueous humor. We talked about this fluid that is providing nutrients to the cornea, and then it kind of makes up that empty space that flows through the pupil. So I guess it's not anatomically dead space. It's just the pupil is a space. It's a hole. And this aqueous humor flows from behind the iris through the pupil and then just kind of hangs out and dances along, may listen to some good music, who knows what, and then just kind of dances around and feeds the cornea. So it's pretty important there. But that's where it comes from. It comes from these ciliary processes within the ciliary body. The other important part of the ciliary body is it has these zonular fibers. These zonular fibers are these fine ligamentous fibers. It's just a fun word to say, let's face it. And that basically attaches to the lens. So basically, the ciliary body holds these zonular fibers that ultimately holds the lens within our eye, which is directly behind the iris. Directly, the pupil is right there. So if you look through the pupil, the next thing you're seeing is literally the lens. That's the next structure you're seeing. Yes, eye anatomy gets me a little excited. I'm sorry. Okay. So why is this not going forward? There we go. Okay. Next. So again, those zonular fibers through the ciliary body help control the shape of the lens. When these actually contract, so the zonular fibers are actually connected to the ciliary body. So they're kind of these little pieces of thread that come off the ciliary body to hold the lens centered in a perfect world in the back, in right behind the iris. And again, so the ciliary body moves and it's different. We think of a contraction and we think of the muscle pulling something towards it. The ciliary body is a very unique muscle because when the ciliary body is relaxed, it's actually pulling on the lens or it's pulling on those zonular fibers to actually, that's when it's relaxed. When it contracts, it releases the tension by pushing the ciliary body. So it pushes upward to let the lens actually relax. So when it's contracted, the ciliary body is relaxed. It sounds kind of crazy and convoluted, but it's kind of an ingenious system to let the lens be mobile, there we go, and allows the lens to actually do what it needs to do. So again, it allows the anterior surface of the lens to bulge forward. That increases the power that allows somebody to focus on something up close. And then to look in the distance, the ciliary body relaxes. It pulls the lens so it's taut. And then therefore they can see in the distance. And that ability to move from distance and up close decline with age. So there's a question, can those ciliary body be affected by trauma affecting the lens? Abso-freaking-lutely. Yes, trauma can absolutely affect that. The lens can become detached. Those fibers can become detached. That's obviously not a good thing that requires emergency surgery. So good question, Cynthia. So next up, we have the choroid. So the choroid lies between the retina and the sclera. We talked about that connective tissue that goes 5/6 around the eye. The choroid is just between those two areas, and it's a very vascularized structure. It is basically like almost 100% blood vessels. It basically feeds the retina. It gives the retina the nutrients. And we haven't even talked about the retina, but just because it's such a huge structure, this is where all the blood happens. If you wring out the eye, this is where all the blood comes from, is the choroid. So again, super, super important. It provides nourishment for the outer layers of the retina. So incredibly important. So again, choroid, we have the iris, and we have the ciliary body. So that is the part that, again, we talk about. Now, we're going to get into something that's a little bit more confusing. I apologize. It just happens to be what it is. But we have the angle. We talked about the ciliary body, how it creates the aqueous humor. And this aqueous humor, is just kind of doing its thing, coming from the ciliary body up through the pupil that's created by the iris into the anterior segment of the eye between the cornea and the iris. But where does it go? If you keep making it, it's got to have a place to exit. And the place where it exits is called the angle. This is a structure posterior to the cornea and anterior to the iris. So basically, if we think of where the cornea and the iris meet, it is an angle, like a triangle, all the way 360 degrees around. And that is where the angle, this is where the actual aqueous humor will eventually exit the eye. So we have the root of the iris where the actual iris is, kind of clamped onto the sclera. Then you have the anterior surface or the very front surface of the ciliary body. Then you have an anatomical structure called the canal of, the scleral spur. The scleral spur, good Lord, it's tongue twister night here. Then we have the canal of Schlemm that takes us to the trabecular meshwork. And the trabecular meshwork is finally that spongy area that really converts aqueous humor and gets it back flowing in the bloodstream. So therefore, that is the angle. And yes, I understand your head is spinning. Good thing you're not doing shots for every time you get a new terminology, because, oh my gosh, it'd be like watching a political debate or something like that. So anyway, the angle, we have the aqueous humor goes through the trabecular meshwork. The trabecular meshwork contains pores that takes the aqueous to Schlemm's canal. I have never seen the Dr. Seuss. That quote, that I might have to borrow that here, Cami. I like this being the Canal of Schlemm is just south of Hogwarts. I am so sorry. I might be a little squirrely tonight. But oh my gosh, that is absolutely hilarious. So the canal, Eric, I promise I'm going to get to you as soon as I go through. Trabecular meshwork contains pores that takes the aqueous to Schlemm's canal. Then the aqueous leaves the eye through aqueous veins that penetrate the sclera. And obstruction here leads to increased eye pressure. That is the big one, Eric, of what you just asked for. So thank you for leading me right into that here, because that is the problem. Because if we are blocked, there's nothing that really turns off the aqueous humor being produced through the ciliary body. So if that, keeps on making stuff, there only gets to be so much portion before there's going to be some type of damage. It's not like the eyeball is going to pop, but this is exactly where glaucoma comes from. So yes, and again, we'll talk about that more as we get into the actual disease portion of the course. But yes, that is exactly what we're talking about here. So again, not going to really get into that here too much, but again, the angle, and again, I'll break this down again a little bit differently next week. Next week, we'll build on this, but yet really do a good review so you guys can kind of understand what we're actually talking about here. So next up, we have the lens. So the lens we've kind of talked about, we know it's held by these zonular fibers that are attached to the ciliary body. It is biconvex, meaning that both sides of the lens, the front and the back, bow outwards. And the center of the lens is just 3 millimeters from the cornea. So you know how small that entire area is. The lens itself is only about 9 to 10 millimeters. So a centimeter big is the diameter of the actual lens. At the equator, which if we think about the globe of the Earth, the equator is the central part. That's where all those zonular fibers actually attach. So we have the transparent, or we have the capsule. This is a transparent outer elastic envelope that hardens with age. This is why we lose that magic age at 40. That lens doesn't like to focus. And you need two different type of lenses to help focus. We call it bifocals, but that it's the capsule hardening that doesn't help there. And then we have the nucleus, that is the central portion. The nucleus itself actually doesn't develop into our 30s because that's where the center part is just kind of getting hardened as it continues to grow from the inside out. And then we have the cortex. These are the outer lens fibers. So there's, different parts of the lens. Again, not getting nitpicky into actually the parts, but it's just to show that all of this stuff is actually pretty darn complex. And it's really freaking cool because this is where all our vision, how it happens. So the lens, I call it the onion effect. It grows from the center outward, and the lens never loses a cell from birth. And so therefore, there gets to be a point where the lens just grows too big where it can no longer function. It does happen generally in our 40s. That doesn't allow us to focus up close anymore, and that's exactly what happens. So as we get now towards the back of the eye, so we made it through the front to the middle section, now we're going to talk about the back of the eye. So this is the posterior segment. So the vitreous humor, just because, why not? Let's face it. We've got the aqueous humor. So of course we need a different kind of humor because these are all freaking funny here. Oh, hello. So anyway, the vitreous humor, it is 2/3 of the inner volume of the eye. This is the big chunk. We've got the anterior segment and then the intermediate segment, and then it's all the rest of the eye. This is where the vitreous happens. It is a gel-like substance that is 99% water. It is thick and viscous. It is also transparent. It's a matrix of collagen fibers with a mixture of hyaluronic acid for funsies, I guess to say. But the most important part of the vitreous is not just to be like a fun little gel that you can play with if you dissect an eye. It's actually a shock absorber. So let's say if you're me and not really paying attention to where you go and you run into a wall, like I may have done at work today, that's always fun in front of a patient. Thinking too hard and not paying attention to where I go creates for a little humor, right? Oh, that's so funny. Vitreous humor and humor. Anyway, it's a shock absorber. So when you bang onto something, it literally shock absorbs so the structures of the eye stay okay and don't get injured. So hopefully that doesn't, again, our body has so many different reflexes to really help out. So yeah, Alex, absolutely. The lens, it can actually get too big. And that's why they recommend having cataract surgery before the cataracts get too bad. The cataract is a clouding and a thickening of the lens. And that's why they recommend, because otherwise, it's just you have more complexities with cataract surgery. So yeah, absolutely. I love how you guys are already putting this stuff together. It's great. And just from a teacher standpoint, loving every moment of this. Okay, so then we can also have these things called floaters. The vitreous itself is anchored at so many different parts of the back of the eye. We have the ora serrata, which is the very outer part just behind the iris at the ciliary body. The vitreous is attached, and that's called the ora serrata. It's where the ciliary body turns into the retina. Then right at the smack dab middle of the back of the eye, we have the optic nerve. And then there's various points throughout the eye. But as we age, because if we don't age, we basically are dead, the collagen fibers kind of break away and they condense and lose their transparency. And boom, you got a floater, which is a black area of our vision. Again, be careful of what you're educating people because you've really got to watch. There are so many different things that we can, cause this. But again, the vitreous humor is where floaters are going to be, and they really need to check out, is it a normal aging process or, oh crap, it's something worse that we need to worry about here. Next up, we have the retina. That's fancy for retina. Basically, this is an extension of the brain. This is one of the most important parts. It needs a lot of blood. That's why the choroid is attached to the retina to give it the blood that it needs. And again, there's 10 different layers. We have the retinal pigment epithelium. That's, again, the basement membrane that attaches the retina to the choroid. So incredibly important. We've got photoreceptors, we've got nerve connections, and we have the nerve fiber layer. So again, I'm from Michigan, so of course I am saying, I'm so sorry. I could not resist my retina comment here. And there might be different things that I do. So please, Gina, thank you for just laughing, or hopefully you're laughing here. But no, retina is the proper terminology here. But if you want to be like you're fancy, fancy like Applebee's, use Retina. It'll throw people off every single time. So we have the NFL, not the NFL where the Lions played and actually won last night. You know, we've got so many different things with the retina that are going on that are just so incredibly amazing. If you look at the amazing thing, when light actually enters the eye and hits the retina and absorbed by the retina, it is literally like a 2-year-old drawing, not even a 4-year-old drawing. It looks like a 2-year-old. And somehow through the magic of different nerve blockers and, you know, different things to kind of get out the excess noise, we get beautiful vision that actually is perceived when nothing else is blocking it or no other type of visual impairment is going on. So it's just absolutely amazing what can actually happen here. So the retinal photoreceptors, we have 2 different types of retinal photoreceptors. These are the big heavy hitters that actually absorb light coming into our eyes. We have the rods and we have the cones. So we have the rods, those are responsible for dim lighting. That is where it's very, very poor vision because again, this is how we can see when it's not bright outdoors. This also picks up motion or action. Any type of movement that a person is able to pick up comes from our rods. And there's about 125 million of these bad things, bad boys, bad girls, whatever you want to call it. But they are so responsible for a majority of the back of the eye. So again, rods, dim lighting, poor vision, action, 125 million. Then we have the cones, not Madonna's cones, but we're actually talking about cones. These are photoreceptors in the back of the eye. This is basically allows us to see in normal lighting. And then there are small visual angles. What the heck, Doc, does small visual angle means? This basically is stating these are fine detailed vision. The cones pick up fine detailed vision as well as color vision. And there are 6 million of these. So 125 million rods, there are 6 million cones. So you can see the majority of the retina is made up of rods, and then we have the cones. So how is the retina actually, you know, kind of happen here? What the visual makes my eyes hurt. I love it. I love it. It's kind of true, especially on a Monday night, depending on what time zone you're at. So the central part of the retina itself is made up of the macula lutea or the fovea centralis for fun. Why not just call it 2 different things? But you may hear it called both in the industry here. The macula is generally the macular area where the cones are located. The fovea centralis is dead smack dab in the center part of the back of the eye. And that is literally where all of the fine detailed vision comes from. If there is any damage to this area, lack of blood flow, scarring, you name it, there is absolutely no vision in this area. So again, there are no rods located in the macula. So question, so the rods and cones are attached to the retina and filter different types of light? Absolutely. So, and yes, just as you put, the fovea macula is confusing. The fovea itself is the center of the macular area. So yes, you are absolutely correct, Alex. So you did get that correct. I pray to God I didn't mention that wrong, but I'm throwing out so much information. It's possible. So thank you for clarifying. The fovea itself is the dead center of the macular area. And again, there's no cones in that area. In the peripheral retina, so once we get away from the macula, we start losing cones dramatically and it all becomes rods. So again, there's no color vision with our rods. So this is, you know, if you think of 50 Shades of Grey for a terrible, terrible analogy here, the rods are literally 50 Shades of Grey. Again, that any damage causes night blindness. So that's really, again, our different tones of gray, different things, ability for us to see shadows comes from the rods itself. And then again, we have the pigment epithelium that attaches to the choroid. So that can actually send nutrients to the retina itself. We'll talk a little bit more about the retina next week again, so please know I'm just trying to give you an overview of everything, and then we kind of fine-tune all of this area, just like our vision is fine-tuned, and we'll do that next week. So the optic nerve is in the very back of the eye. All the visual impulses from the retina to the brain have to travel through this area. And there's about 1 million axons that make up, or 1 million nerve fibers that actually take the visual information from the retina and transfer it to our brain. At the optic nerve, where the optic nerve comes together from all the nerve fiber layer, from all the retinal layers, all of those transparent nerves, they come together at the optic nerve, and there is no photoreceptors at that area. So that creates the physiological blind spot. Not one person has vision at the optic nerve because there are no photoreceptors to actually absorb any vision from that area. Now, because we have 2 eyes, you generally don't notice your blind spot, but yes, you can absolutely find it. And again, we'll kind of talk about the actual location, or the book does if you don't want to wait until next week. But we'll go, we'll do a commercial break, and then we'll come back and resume that next week here. But basically, there are arteries and veins that branch out of the optic nerve area. And again, that supplies the inner 1/3, the part of the retina that's attached to the vitreous. That's where those arteries and veins supply the outer layers of the retina that are attached to the vitreous. And then the choroid attaches, that supplies nutrients to the rest there. So there's 2 different blood flows to the retina. Obviously, if one of those blood flows are damaged, bad things happen with a person's vision. So the optic nerve itself, again, as we talked about, it enters the globe through the sclera, and that is through that area called the lamina cribrosa. It's the Swiss cheese area of connective tissue that allows the nerves to actually go through, and we call that the basement of the physiological cup. You will hear the word physiological cup again when we talk about glaucoma. Again, not that worried to lose any sleep over what a physiological cup is. Then we got to get all this information that our amazing eyes are actually seeing back to the brain. And that's where the visual pathway comes in, because this hasn't been enough yet. So the visual pathway, you take the 2 optic nerves from our 2 eyeballs, and they connect at the optic chiasm. Where it gets super fun is that half of the nerve fibers that leave one optic nerve cross to the other side. So you literally are getting a cross-like structure. So the 2 eyes end up joining. So for example, the whole left side of somebody's vision starts transferring to the right side of somebody's brain. And that's what happens at the optic chiasm. So basically, all the fibers that are pointing to the left side of the vision, so for example, it'd be the nasal side of the left eye and the temporal side, or the outer part of the right eye, they go through the optic nerves and then combine at the chiasm to keep the vision that's coming from the left side of each individual eye, they keep it together. And so that's what happens at the optic chiasm. This becomes important because when you do have a stroke or something like that, you can actually find out where exactly a part of a person's vision, if there was a defect that's happening and they have visual field defects, this is why, okay, this person doesn't have vision on this side or this side. Well, you can kind of determine, okay, this is about in the spot where this actually happened. So I know that this is extremely confusing. We talk about this a lot more, especially in the visual field. What I want you to know is that at the optic chiasm, half of the vision from either the left side or the right side will cross and join with the left or right side of the other eye. So the left stays with the left field of vision. So anything on the left side of a person's vision goes to the right side of the brain. That crossing between the 2 eyes happens at the chiasm. So another way to put it, anything on the right side of a person's vision will cross to go to the left side of somebody's brain. So everything crosses and it gets processed on the opposite side of what they're seeing. That travels from the optic chiasm through the optic tract. So we've got the optic nerve that happens between the eyeball and the optic chiasm. And after the optic chiasm, the optic nerve is no longer called the optic nerve, it's called the optic tract. At the optic tract, what makes that more unique is it's got the visual fields of both eyes connected, but it's either the left side visual field on the right side or the left side on the patient's right side. So hopefully that didn't lose anybody more, but the optic tract is the combined vision of the appropriate side as it takes it back to the visual cortex in order to be actually processed and become the usable vision we actually get. Now, at the lateral geniculate body, this is the last step that the optic tract takes the vision to. This is a relay station, and the fibers are then spread out in a fan-shaped manner to both the extend through the parietal and temporal lobes. And then what I don't have on this slide is it takes it ultimately to the occipital lobe, which is in the next slide. So the lateral geniculate body is taking and fanning out the actual vision as it gets back to the occipital lobe at the back of the brain. And that is where all of our vision is actually processed. So in the occipital lobe, we have the visual striae area, and that's where conscious recognition happens. That is where the magic happens, where all of our vision comes together to bring us the magic of sight. So we've talked about a lot, but are we done yet? Oh, heck no. We've still got to talk about the muscles because the eyes move. If you watch me, I mean, oh my gosh, I may roll my eyes. I may, who knows what. Or you may be rolling your eyes. They might be jogging around in your brain by this point because of all this information. But we got to talk about how the eyeballs themselves actually move. So we talked about the levator. We talked about the orbiculus oculi. Now we're going to talk about the muscles that are literally attached to the eyeball that make it move and do more magic. So the medial rectus, that adducts the eye. The medial rectus, so medial, we think of middle. So the middle, so it's towards the nose. Okay, medial rectus, got it. Towards the nose on each eye. So we've got 6 eye muscles, but we've got 2 eyes. So that means we have 12 total eye muscles. So what you do on one side is just like math, you do to the opposite side. So the medial rectus, they move both eyes towards the nose. So if you cross your eyes, you're using your medial rectus to do it. It moves the eye towards the nose. The lateral rectus is on the outer part, lateral meaning outer. So therefore it moves the eye outward or abducts the eye. It takes it away. It takes the eyeball to the outer part of the eye. I don't know if it works out. Just trying to give you little matisms to try to memorize all this stuff. Next up, we have the superior rectus. That involves moving the eyeball up. And then we have the inferior rectus, and that depresses the eye. I promise hopefully this class is not depressing. But again, it depresses the eye, moves the eyeball downward here. And the rectus muscles themselves, where do they connect to the eye? They connect very close to the limbus. So the limbus is the area right where the conjunctiva meets the cornea. So the rectus itself connects right there, and it's connected by conjunctival tissue. If you happen to look and pay attention really close to your eye, you may see a little elevation in the conjunctiva just in back of the cornea. That's actually where one of your muscles may be inserted. So especially for those like with thyroid eye disease or something that caught, some type of inflammatory disease, you can actually really just tell where the rectus muscles are actually attached to the eye. And if there's inflammation in the muscles, that's obviously going to cause more issues. So again, we've talked about 4 of the muscles. The final 2 are the more complex muscles. And so we have the superior oblique. Again, it's called superior because it's on the top, but it intorts the eye. It moves the eye inward. So it rotates the eye. So we've got the rectus muscles that move the eyes up, down, in, out. Then we have the obliques that either intort, that's what the superior oblique does, or the inferior oblique, that's X towards the eye or rotates the eyeball outward. I think I see a hand up, Gwen. And Gwen, I think you're still muted if you're trying to speak there. So if you have a question, feel free to pop it into the chat, or just feel free to unmute yourself here, so I can make sure I answer all questions here. I did mute everybody, but it's supposed to. Gwen, can you talk now? So I just sent a request to unmute. Hopefully that helps. I did leave it when I did mute everybody. I left it that you guys have the ability to unmute. Let's put it that way. Hopefully this works. This is my first time doing it, so I apologize here. Again, the big thing, the take-home thing with the eye muscles that I want you to know, again, what the rectus muscles do and the superior obliques are responsible for rotating the eye itself. So rectus muscles, up, down, left, right, it's not a bad idea. I feel like those are more basic. You can kind of know, that the superior, okay, the word superior means up. Okay, so that's going to be something that it moves the eyeball up. Medial rectus moves it towards the nose. That's things that I'm going to expect you to do. And then the oblique muscles, again, just know that they kind of rotate the eyes, make the eyes more so go in a circular motion. That's what I'd like to know. I do have just a visual depiction here. Again, not expecting you to memorize that or anything like that. And then for those that are have very functional vision, I just have some pictures of the back of the eye. None of the exams or the test will be making you point out anything to label something or anything like that. So please know there's physically no way, and nor do I feel like there's any need for that here. So really quick, just to, so yeah, the superior oblique rotates inward, the inferior oblique rotates outward. Yes, that is correct, Jen. And I'm not going to actually go into more specifics than what I just laid it out there. So, yep. So just really quick, just to go through some dates that are coming up. So we have that research project that is due. Basically, what I want you to do is go into e-learning, drop your top 3 topics of what you'd like to write your research paper on. Any type of something that can cause a vision impairment is what I ultimately want you to put in there. Do your top 3. Obviously, label is your interest of 1, 2, 3. I will try to oblige, but because we do have that part at the end of the semester, I try to limit how many people. We've got 42 people. Again, there's a ton of things that cause vision impairment. So we will have some repeats, but I try to do this. And plus, it's free points. I mean, oh my gosh, please submit. So therefore, I can know what project you want to do and you get some points out of it. So the topics, again, go ahead and make sure the projects for the research project are literally any type of eye pathology that causes vision impairment. That's what I want to see here. Something that you'd be able to write a good quality, 10-page research project. And it's 10 pages of writing, not just the cover page and everything like that. The reference pages and stuff. It's 10 pages of actual quality writing. So that's what the projects need to be about. And then the discussion posts do have specific dates as well. The module 1, so next Sunday, there will be a quiz over what we talked about. It's 5 short questions just to make sure you're staying up on top of everything. And then there is a discussion module that will open next week because this is a twofer. This module has 2 different weeks, so I want to be able to lecture before you guys actually have the chance to converse with everybody. I'll be honest, the banter and everything that I'm getting from the chat and everything like that, I'm really, really excited for this semester to work with you guys and go through everything, because I do know that this is a lot of information, and you learn so much from each other, and everything like that. So again, discussion module, that will open next Monday, and then you have till September 22nd to do it. And then, my golly, we already get to our first exam. So talk about a rush, but it's literally just this week and next week. That is what exam 1 is all about. And as I've done in the past, I will absolutely sit in and do a study session where basically you can hop on and off the study session, ask questions. It's not unheard of for me to kick back on a Friday evening. I may have a beer as we are going through and answering questions, but it's a very laid back event. And I even post it for those that may want to. So we would definitely plan on doing a little study session next week. Any suggestions to help with memorization? This entire lecture will be recorded. So heaven forbid you want to actually listen to me again, you will have that opportunity. So you can listen to it, whether listening is your thing, whether you want to. I'm laughing at the comment that just came through the chat of research paper topics, bar fights and how they can cause eye pathologies. That is absolutely true. But traumatic brain injuries obviously is a whole thing. So there you go, Chester, right there. Oh my gosh. So anyway, we'll sit down, we'll have that little discussion with the actual, study session. Hopefully that helps you guys. We'll plan a time that's going to work for everybody there. Oh, good golly, my favorite beer. It's hard for me I'm not a big stout or the really heavy beer guys. I'm from Kalamazoo, so I'm not gonna lie. I love Bell's. I'm actually friends with the Bell's family. So I do enjoy, pretty much anything they come out with. I have to watch myself with some of their beers because they can hit me pretty hard here. So we'll put it that way. I'm going to go ahead and unmute everybody here to be brave, and feel free. What kind of questions do we have?
Hi.
Hi.
Hi, Doctor. I was wondering with regard to, I don't know what the technical term is, but people that are born with lazy eye or have that condition, is that when you have a dysfunction of the muscles? In other words, the muscles are not performing properly, and that's what causes like one eye that's going
Yeah,
or
so
kind of slanting inward.
absolutely. So it's what causes what's called amblyopia. And so that absolutely is a vision impairment. It can be a topic for the research paper and everything like that. So yeah, that can absolutely cause that.
Oh, and may I ask also, with regard to whatever visual impairment we choose, part of it will need to address a treatment protocol, right?
Yes, yep. Any known treatments or anything like that out there? Yep, absolutely.
Okay.
Any other questions?
So, oh, sorry.
Go ahead.
So my name is Cami, and my question is more a technical question
Yes.
about how to use this application, this WebEx. It's so different than when we were taking classes last semester. I cannot figure out when I'm trying to relay a message or to see other people's messages. Every time I attempt, or I have to like start it over. So I'm just wondering if I'm doing something wrong, like to see people's messages. It won't show me messages. I have to like restart it. Not our session, but
Restart the
like
chat session.
Yeah, like I have to close it and open it back up to see the chats. It's only showing me like 2 at a time.
I'm gonna direct you to the help desk.
Okay.
Because they can actually look on your screen and kind of sample and troubleshoot with you. And then just make sure you have the latest version of WebEx downloaded. So if there's any updates or anything like that, that'd be my easiest one. But I would definitely the help desk is very, very helpful. That's an awful way to put it, but hopefully you understand. They're just more technical than I might be, unless anybody else has any thoughts.
Okay, and then my other question just really quick is when I have my video stopped, like so that you can't see me, like right now I think my screen is on, but when I have it stopped, like I disappear completely. Can you guys see me just out of curiosity?
Yes.
I can see you right now.
Okay, what about now?
No.
No, I just see your name.
Oh, my name. Okay, that's fine because I can't even see my name. It just says like I'm disappeared. It says video stopped and like
Okay.
it doesn't show anything else. So I was just making sure that it looked like I was still present. It used to say my name and now it doesn't. So I just wanted to make sure.
Yep, on my end, and I have a whole class list here too. That's showing me who's actually here. So it's kind of cool.
Okay, well, thank you so much.
So just a quick question about the projects, the
Yes.
choices, the topics. So all you want is just 1, 2, 3. You don't want us to spell it out. You don't want us to write a blurb. You just want just the 3 topics.
Just the 3 topics. I called this the KISS method. Keep it simple, stupid.
Perfect. Thank you so much.
Absolutely. Not making this hard.
I appreciate that.
Hi, Dr. J. My name is Haley Hilliard. I just had a question about our quizzes.
Yes.
When we have our quizzes, like what's the format of that? Is it more like multiple choice? Do we have to elaborate on things? Like what does it look
No,
like?
it's just gonna be like multiple choice or true false.
Okay, perfect. Thank you.
Yeah, no problem. Yep, the exams will be a little different, but we'll go into that next week.
Dr. Johnson, I'm sorry, could you tell us where we state the 3 topics that we're interested in?
So if you want to just put it on like a Word or Notepad or something, and then you'll actually submit it into the e-learning Dropbox. There's actually a Dropbox for that, where you just upload your responses.
Oh, okay. Thank you.
I have a question about the study group. I'm sorry.
Go.
The study sessions that you were talking about, you said they were going to be probably on Fridays evenings or
Like the Friday before the test, so like next Friday.
okay.
Is what I was thinking. So yeah, not a normal Friday night thing. No offense.
Okay. Thank you.
Yeah, you're welcome.
Will those study sessions be recorded?
Yes. Yep. Anytime I go on WebEx, just for those, because I know all of our schedules, this is supposed to be asynchronous. I do record everything. So far, I have not gotten in trouble for anything I've recorded, so we've been okay. Because I know I don't have a filter. So yeah.
I had a question about topic selection.
Yes.
Will visual issues due to stroke fall? I mean, I was thinking kind of under
100%.
TBI, but
Yep.
what?
So TBI is actually different than a stroke.
Oh, you broke up.
So yep, I would actually break that down.
Okay. So you said
And
it would be
Tammy,
under
I
what?
love that you're going to the football games. That's awesome. So yeah, absolutely.
Dr. J, when I asked my question about stroke, you broke up. What? I didn't hear what you said.
Oh, no problem. I'm so sorry. So basically, don't combine stroke and traumatic brain injury. I like to keep those as 2 separate topics. But yes, stroke is absolutely very much a topic you can use.
Okay, perfect. Thank you.
Yeah, you're welcome.
Dr. J, this is Lisa.
Yes.
I'm not sure if the purpose of this topic is because it's of interest to us, because my topic is probably something you've not heard of and it's not recognized in this country, and the research has been done in Switzerland. Is that still okay to choose?
Absolutely. Can I ask what it is? Or you can message it to me. Or
Okay. Yeah.
I am
Slammers.
all about it. Because
Okay.
you're correct. So please, yes.
Ooh, how do you spell that?
F as in Frank, Lammers.
Okay. Color me intrigued.
I was gonna say it's not a lot that I hear something. I'm like, oh man, I'm intrigued. Okay, there we go. Let's do this. You guys
Great.
are awesome.
Let me see. I have a question about the time limits for quizzes and tests.
Yes.
How much time do you give us, or does it vary for different
It
tests and
does.
quizzes?
So test, midterm final, those are all timed. You guys will know the times beforehand. Everything will be adjusted. If you happen to have accommodations, that will be adjusted. If for the quizzes, they're untimed.
Okay. And
So-
the tests, because if I mean, I don't care about outing myself. I am with the I get services through the Office of Disabilities, and I was just wondering, like, you'll just automatically add that on there?
Yes.
Or
Yep. I go through and edit all the times and everything. So yeah, I have a whole portal that I can see, so I don't have to keep track of all disability services emails and things. So I go through a portal. I've got a spreadsheet that I make sure I adjust every single one.
Okay, cool. Thank you.
Yeah, you're welcome.
I had another question, please.
Yeah,
With
absolutely.
regard to whatever topic we choose, can we use in terms of like emerging treatment protocols, or
Oh,
would
for
they
sure.
have to be?
No,
Oh,
absolutely.
okay.
Emerging. So that's where I have like in the syllabus, it kind of discussed, current treatment as well as, what might be coming. So yeah, I mean, I really want, when it comes to the research project, please know, like, and we'll discuss this too as we get closer to the outline being due, but I want you guys to make this whatever's going to make it interesting for whatever topic you guys choose. What really makes you want to learn more about this? Because, I want you to get something out of this. This is not something for just to plug and chug and create some points in this. I want you to literally get something out of this. Hope that helps.
Yes. Thank you.
You're welcome.
Hi,
Any other
Dr.
questions?
J. Yes. My name is Taylor. I've really enjoyed your class so far. My question is, so I am visually impaired,
Okay.
and so I appreciate you not having us label anything, very helpful, for the exams. But
Absolutely.
I'm just curious, do you have any advice from like what you've heard of other visually impaired students doing, like to help study for your class? Because I know the pictures probably are pretty helpful, but if we're not able to like use those.
The biggest thing are you on campus, Taylor?
No, I'm in Arizona.
You're in Arizona. Okay, so that's nowhere close. So stay cool out there. But honestly, I've had some folks that have just decided, you know what, I'm just going to go on Amazon and actually buy just a Model I. I wish I had a better answer for you. But just so you can actually feel and touch and everything like that, I've had plenty of folks end up doing that.
Mhm.
And when the pictures, again, I try to describe everything. I don't want you to get too bogged down unless you are, you want to kind of feel and understand and touch and everything like that. That I'm trying to be very fair and cognizant of that because I've taught this class for about 14 years. And so there's always quite a good handful of students that are visually impaired or even totally blind that take this.
Mhm.
And so when I do test and everything on it, I'm very aware of that, but I know it makes the learning process that much harder for them. And I try to be very sympathetic as well towards that. So the biggest thing is just, you know, kind of just the memorization, repeating the lectures, whatever you happen to might, you know, do for a different learning topic, whether it's, you know, making yourself little audio memos to listen or, you know, things like that.
Awesome. Okay, thank you.
You're welcome.
Do you have a 3D model of the eye that you recommend from Amazon?
No, any of them are actually really good. I mean, it doesn't have to be expensive for, I mean, just to give you that basic, okay, this is kind of how it is. You know, I've seen one on there for like $30 that I feel was pretty decent.
Okay, cool.
And I know as a college student, any type of money you're trying to spend, I mean, it's like, I get it, trust me.
It just seems kind of cool. And honestly, because I'm visually impaired myself, I don't know if I could find one that has an optic nerve, but I have optic nerve hypoplasia and I
Okay.
have little nieces and nephews. And I
Mhm.
thought it might be cool to actually like show them, like, this is the little part on my eye that doesn't work.
Exactly, exactly. I've had so many folks, and then, you know, I've got other other students that are totally visual and just decided to, hey, I'm going to teach my family about the eye because I think this is so cool. So I love it. I love it.
Dr. J.
Yes.
Hey, this is Christy. And so I'm blind as well, but I was at a CSUN conference. It was probably a couple years ago. And there was an actual talking eye. So it was a model, but then when you touched it, it would say the parts of the eye. And it was really, really cool.
No kidding. That's amazing. I love it.
Video. Mute.
Yeah, thanks, Christy, for sharing. I figured there's probably something like that, but I have never seen it, so that's really cool. Any other questions? Well, hearing none, I'm actually going to turn off the recording. I can't thank you guys enough. This was one of the best lectures I've done virtual so far. I love it. I'm so incredibly excited for this semester and am looking forward to working with you all. So have a wonderful night.
Thank you so much.
Yeah.
Bye, thank you.